Hello, this is the video tutorial for modeling the mounting body in Fusion 3, and is part number 7310, revision 0. And we're going to model this part, which is part of a vise stop assembly. We're going to model this in Fusion 3. Okay, so let's look at this part. It is a aluminum extrusion part. It is flat on two faces, has an end and a mounting point, and then it's got a series of holes that mount to the back of different size vices that have different hole patterns here. So this should fit, I believe, a 6-inch and a 4-inch standard mill vise. Okay, so we're going to start off. I think the easiest thing to do is to make an extrusion, and we could either make that extrusion for the end view and cut these sides out, or we could do an extrusion of what we see from the end and cut away the top. So it's kind of semantics. I'm gonna opt for the first scenario. So I'm sorry, the second scenario, and we're gonna model this profile, extrude it, and then we'll come back and cut this radius off on the top. Okay, so let's go to Fusion. Make sure you open a file, and we're going to save that file as our part number, which is 7310 underscore rev underscore 0. Okay. Save it in a place where you know it's going to be, and then you're going to put your first initial and last name. Can't even spell my own name. There we go. And let's hit save. And what that does is you want to save pretty early on, because that sets the autosave function in Fusion. So we're going to make a sketch. We'll go ahead and do that in the top view, because that's how it was in the drawing we have. Okay, we're going to start off the line tool. We're going to start at origin. We're going to go left. We're going to click and hold the button down so we can make an arc. Make that arc. We're going to lift up, go left, up, down across. Now, it's defaulting to a tangent arc. We don't want that. But we can fix it. We just go back and make this shape. Let's take away the tangency where we didn't want it. Should be able to drag our arc down. Click on the arc, click on the line, and we're going to make those tangent. And okay, so that's the basic shape. We want to put a dimension on one of these arcs. And according to our drawing, that arc is 250 thousandths. Okay, and now we can go and highlight both arcs by holding the shift key down. Allows you to select multiple things, and we're going to make those equal in size. And then this horizontal line that I've just highlighted and the second horizontal line, we also want to make those equal in length. Okay, the distance from the end of the block to arc center is 0.58. Okay, and then we're going to put in our thickness here on the right hand side, which is 3/4 of an inch, or 0.75. And then we need to dimension the end. And that height is shown in the left view is 950 thousandths. Okay, so now we're going to put in a relationship. We want the center of this right line and the center of the one on the left to be horizontal. So I'm going to put a center line in here. We're going to create construction and then force that line to be horizontal. And that'll evenly space our part here. And the only other dimension we have left is the overall length, which is 8 inches. Okay, so if we expand our sketches on the left, this should have the little padlock symbol, meaning it's fully constrained. You don't necessarily need all the dimensions on the drawing itself, provided it's fully constrained and the critical dimensions are there. And now we're going to extrude this. So our part is 625 to center, and then the arc that's centered on that is 0.6. So if we add those together, we get 0.6 plus 0.625 gives us a little over 1.25 inches. So we're going to go ahead and make our extrusion 1.25 inches because we're going to be cutting off the radius on that. So we need a little bit of material there. So we're going to go finish sketch, we're going to extrude, and I like to go to a 3D view at this point, and we're going to go a distance of 1.25. And hit OK. So we've got our initial extrusion. Right now it's more or less a symmetrical piece. Now we're going to cut our round in the top. So let's look at it from the larger of the two views, and we're going to sketch on that face, and we're going to go ahead and draw a circle, and we're going to place that circle on the surface, hit escape. We're now going to create a line from center of the top to the center of the bottom. We will make that line we just created a construction line. Then we're going to select on the center of our circle and hold the shift key down, select our center line, and we're going to make those two coincident. We don't want it on midpoint, we want it coincident. And then we need to put the dimension from center line, center of the circle to the base of the part, which according to our drawing in the side view is 0.625 or 625 thousandths. So we're going to put a dimension from the bottom edge to center of the arc or circle, and it's 0.625. Alright, now we need to set this diameter. According to our drawing, it's 0.6 inches. So if we were to dimension this with a diameter, it's double that. So 0.6 plus times 2 is 1.2. 1.2. And that gives us the arc we need to make. Okay, so now we're going to sketch the zone we want to remove. So there's a couple ways we can approach this. I'm just going to draw some lines to the model itself and intersections. And then we're going to trim off what we don't want. Now in Fusion you don't necessarily have to do that. It allows you to select zones, but it's a habit I'm in. And it looks like I accidentally deleted my dimension. So I'm going to go ahead and put my radius back in there. And at the moment, this can be canted right to left. So you can either make a horizontal relationship between these endpoints, or you can make the legs that we drew equal in length, and that'll balance this out. We now have a fully constrained sketch. We can hit finish sketch. Let's go to a 3D view, and we're going to do you could do an extrude or a press pull, but we're going to do an extrude, and we're going to select the section we want to use. It's going to be a cut, so we'll change it to a type cut. It's going to go one side, it's going to go through all, and we'll flip the direction of it. So in red it's rendering what it's going to remove, and we'll hit OK. Okay, so we got our domed top on the part. Alright, next we have a series of holes that go through the face of this. So what we're going to do is we're going to take a look at that. So we have 1, 2, 3, 4 holes, 4 times. They're 547 thousandths in diameter. They have a chamfer. We're going to put that on later, the chamfer tool for the countersink. But let's do these holes here. So, and they're aligned with this 625 thousandths center line here. So let's put that in. So we're going to sketch on the flat face of the part. We're going to make a line from one end of the part to the other. We'll go ahead and make the line coincident with the edge that projects. And then this isn't, we don't want this real geometry, so pick on the line and we're going to make that construction geometry. Now let's draw our circles. We're going to draw them on that line we just made. You can somewhat make them arbitrary in size. At the moment, there's 4 of them. Okay, and so let's dimension one of them, its diameter, which according to our print is 547 thousandths. So we're going to dimension the first one, 547 thousandths. It shrinks up. Hit escape to get out of the dimension tool. Then we're going to highlight the circle we just dimensioned. Hold the shift key down and we're going to highlight the rest of the circles and create an equal relationship between them. So they're now all the same diameter. Now all we have to do, and they also have to be on this center line we have here. So right now that center line can float. We need to put a dimension from the base to the center line, and it is 0.625, 625 thousandths. From the bottom is where that row of holes sits. Okay, so we're going to go to the mounting body and we're going to go from left to right. So we have a 1 inch 850 dimension. Let's put that one in. So from the edge of the part to the center of the first circle, (1 inch 850). We look at our next circle is 3 inches 630 from the end. So we're going to go from the end of the part to the center of the second one. .63. Alright, our next one is going to go from the same edge of the part to the center of the next one. Looks like I accidentally got a midpoint relationship I didn't want. So if that happens, just highlight the relationship and hit delete, and you can delete that relationship. We go back to the dimension tool and a dimension from edge of part to center of the hole. And this dimension here is 5 inches and 730. So 5.73. Okay, we just have this last hole here. Go from there to center. And according to our drawing, that last one is 7 inches and 500 thousandths. 7.5. Okay, so that's all our holes and their centers, and if we look to the left, our sketch should be fully constrained. We're going to hit finish sketch. We're going to do another extruded cut. We're going to pick inside each of these zones of the circles, telling it we want to modify what's inside that circle. And we're going to do through all. Okay, we're going to flip direction, which should cause it to change the cut. If it doesn't, change it to cut and hit OK. So now we have our hole pattern. Alright, so now our drawing has that with a chamfer on both sides. We could do that now, or we could do it after we put the last feature in. Let's do it now. We just created these things. So if we go to our drawing, if we have a 600 thousandths 90 degrees countersink, what size is it if we're using the chamfer tool? So 0.6 minus the diameter of the hole, which gives us, so it's 0.6 minus 0.547. It results in 53 thousandths. We divide that by 2 because it splits the difference on both sides of the hole. We have a 26 thousandths 5/10 chamfer. You can, if you use the calculator, you can right click and hit copy that number or remember it. And we're going to go to modify and we're going to do chamfers. And we're going to pick the edges of each of our holes on both sides of the part. And then we're going to set our chamfer size of 0.0265, which should give us the resulting chamfer we want.